Hello everyone, this is Shiny from Mydbops, your host for this exciting webinar of Mydbops My Webinar 40. Today's webinar is about cost optimization techniques for AWS Postgres. So we will be discussing simple and effective ways to reduce cost while keeping the database performance high. So without further ado, let's get started.
Hello everyone. I would like to thank you all for joining today for the 40th edition of my DBAs My Webinar. Here we will be discussing on cost optimization techniques for AWS PostgreSQL services, which will actually be a case study of one of our success stories where we helped save around $50,000 for one of our customers, which is a logistic giant in India. So let's dive straight into it. So this will be the agenda for the session. We are going to look into why cost optimization is crucial, the AWS inventory of the customer, how we suggested instance downgrade based on CPU usage, how to optimize cost for instances with provision IOPS, storage reduction, managing snapshots, and what are Amazon Graviton instances, and finally, a summary of what suggestions we provided for cost optimization. So, firstly, why cost optimization? The answer is quite simple. Whether we like to admit it or not, it is money that we are burning, and if we do not do it sensibly, we might end up like this guy. Jokes apart, cost optimization is essential to control and reduce unnecessary spendings, reducing over provisioning of hardware, aligning costs with business needs, preventing budget overruns, and increasing the overall business agility. Now, I hope that we all are on the same page in regards to this. Now, before directly jumping into our case study, here's a short disclaimer. All price calculations are made using AWS pricing calculator and are approximate values. All the prices mentioned are in US dollars. The prices are calculated for both on-demand and reserve instant types and is on a monthly basis. So the cost for reserve instances are calculated assuming no upfront payment and for a period of 1 year. So let's get started now. Firstly, coming to the AWS inventory. Our customer had 4 different AWS accounts, and the following hardware was part of the AWS PostgreSQL inventory, which was being used by multiple apps and services. The inventory included both RDS as well as Aurora instances, and as per our initial analysis, over provisioning was very noticeable here. So the first optimization suggestion we proposed was to downsize the DB instances based on the CPU usage. So this was pretty simple and straightforward. For the instances where memory usage was normal and CPU cores were over provisioned, we observed 2 to 3 weeks of CPU usage and proposed downsizing of the instances to a lower instance type, where the average usage was less than 20%. The proposed instance types with the cost saving is as shown in the table. Similar suggestions were provided for all the accounts, and with this, a total saving of $9.4 thousand in case of reserve instances and around $14.4 thousand in case of on-demand instances was proposed. This was no rocket science, just a bit of analysis. Next section is provision IOPS. Here we analyze the DB instances that were using provision IOPS storage type, and we observe the IOPS usage for 2 to 3 weeks. Now, provision extra IOPS from AWS do provide guarantees performance improvement, but we pay for the specific IOPS regardless of whether it's being fully utilized or not. Also, provision IOPS specially uses SSDs optimized for high throughput and low latency, which make the storage type more expensive. It is ideal though for critical workloads, but expensive if over provision or underutilized. Here we can see the IOPS usage was very minimal. Therefore, we suggested to move to GP3 storage. GP3 storage is an Amazon EBS volume type offering consistent performance at a lower cost. It comes with a baseline 3000 IOPS and throughput of 125 MB per second. So GP3 was a good option as it provided the 3000 base IOPS with no extra charges, which suffices our use case. And if required, we can easily increase the IOPS separately in the future. Therefore, the total savings projected switching to GP3 were around $2.7 thousand per month. So here, as we can see, we are not paying anything extra for the IOPS that we were paying in case of provision IOPS storage, which charge for storage as well as for IOPS. So here we had a good amount of saving. So the next section is RDS storage reduction. This mainly applies for the RDS PostgreSQL servers. For the DB instances where we found out that the actual data size was comparatively low than the allocated storage, but the billing was done for the entire storage volume. So we proposed reducing the storage or storage downsizing till the time of more storage need. So this was proposed for all the accounts. Now, reducing the storage is not a simple plug and play because it requires logical rebuilding of the database to a new instance with lesser storage volume. We cannot create a new replica also in RDS with a lower storage because the storage volume will be same of what we are having in primary. Therefore, the storage downsizing we can achieve by creating a new lower instance type of server. Then we need to do the logical replication to the new server in order to reduce the storage. Now, once the data is migrated and the applications are moved to the new DB instance, in case if future we require more storage, we can simply upscale the storage in the new RDS instance. So the overall cost saving in this section was expected to be around $232 per month. Now we have the snapshots. Manual snapshots in RDS are generally taken to make a database copy of a particular time. It can be used for restoration or new instance creations, etc. Manual snapshots in RDS incur cost based on the amount of storage they consume. AWS charges for total size of the snapshot, and the cost increases if the snapshot are large in size or retained for longer periods of time. Therefore, efficient management like reviewing and deleting unneeded older manual snapshots help to minimize the cost. These snapshots are stored in S3. Therefore, it is required to review it to save the storage cost. So we analyze the all the accounts that we had in our inventory, and here we could see a lot of older snapshots more than a year or two. Therefore, we reviewed it and asked to drop the same. The same was uh, like reviewed for all the four accounts, and we can see we had actually a lot of older snapshots here. So the projected saving when dropping this snapshot came to be around $42,000. So here, if we want any particular snapshots to be kept, then we suggested moving it to AWS Glacier Deep Archive, which charges comparatively less than S3. Here we have given the cost comparison between S3 and Glacier Deep Archive, and we can see the difference. So in case any snapshot is required to be kept and cannot be deleted, we can move it to Glacier Deep Archive and save the storage cost. Next up, we have the Graviton instances. AWS had introduced Graviton instance types M6G and R6G for Amazon RDS and Aurora DB services, which offered better cost performance as compared to the x86 counterparts like Intel machines. It was is supported by Postgres version 12.3 and higher for RDS and 11.9 and higher for Aurora servers. So Graviton instances deliver up to 52% of price per performance, and the performance is optimized in such a way that we get 4 times the compute cost, 7 times the performance, faster memory allocation, floating point performance, and 50% faster encryption performance per core. Additionally, migrating to Graviton 2 from the Intel requires no code changes at the application level. We can just create a new DB instance and we can create a replication in between them. Either we can use streaming replication or the we can use logical replication to migrate from the x86 machines to the Graviton machines. So we and gone through all the x86 architecture machines that we were having in the inventory, and we proposed migrating from x86 to Graviton, and here we can see the cost comparison. The same was done across all the accounts, and we can see the savings projection was up to $3,800 to $4,200 per month. Apart from the cost saving, Graviton instances are also energy efficient, reducing energy cost and supporting sustainability goals. Graviton instances also provide more cores and higher memory bandwidth, which is ideal for scaling applications efficiently. Now we have the reserve instances. Amazon Reserve instances are discounted pricing options provided by AWS along with the on-demand one, where we can get a discount in the AWS billing if we commit to 1 to 3 years of term. Reserve instances is a more cost-effective option than the on-demand one. It offers up to 72% discount compared to the on-demand pricing model. It should be committed for a period of 1 to 3 years, with the prices reducing with higher number of years. These type of instances can be used for a specific or broader region. Here we also get the option to change the availability zone instance sizes within family or networking types also. These are actually best for steady and predictable workloads, and we also saw in our case study that reserve model prices were comparatively very low than the on-demand ones, which we saw in our earlier slides. The comparison was there. So we also get the flexible payment options with reserve instances, like paying all upfront, partial upfront, or no upfront, each option with its own discounts. So it is suggested that in case we have a predictable workload and a requirement of hardware, where we know that we are going to use the particular hardware for a fixed amount of time, whether 1 to 3 years, we can go for reserve instances, and as compared to the on-demand one, which will be a more cost-effective option. Finally, here we have listed all the suggestions that were proposed during this assessment. All the suggestions that were proposed as per our analysis, which each section that we discuss in detail in this session. The assessment projected an expected saving of around $58,000 in case of reserve instances pricing model, and $64,000 in case of on-demand instances pricing model. So the suggestions were proposed, and we had a discussion based on that, on what action items I do not have any dependency and we can take it up, or what action items require a developer or DBA involvement. And based on that, the suggestions were implemented on the system. Now, exercises like these can be performed on a monthly to quarterly basis to examine and analyze the cloud DB infra and save some bucks for your business. So at the end, here we have listed some more cost optimization techniques and best practices to follow when performing a cost analysis. First is to monitor the cost using cost allocation tags. We can tag particular resources for detailed cost tracking and accountability. Then we can leverage reserve instances. We saw what great difference in pricing model and how reserve instances are more cost effective than the on demand ones. So we can definitely move to reserve instances more. Then we can use tools like AWS Cost Explorer, Trusted Advisor, and Compute Optimizer to like analyze where the cost is going and plan accordingly. We can also enable budget alerts and get notifications to avoid any budget overruns, and to make ensure that the resources are allocated as per need, and it's no overruns are happening in place. Then one important thing is choosing the right type of hardware and preventing over provisioning. Based on what workload we are having, if we have the predictability or whenever migrating from a certain workload to a new, then we can make the forecasting prior to provisioning of hardware, and we can prevent over provisioning in place. Now, apart from the listed ones, it is also important to look into performance tuning of the DB instances. with the steps like query caching and partitioning, which can help the DB instance use the resources more effectively. Then we can optimize the backup storage, like setting appropriate retention periods for automated backups to avoid keeping excessive backups, and deleting the unused manual snapshots, which we discussed also in our assessment, how much of cost we were saving. Uh, because this incur additional storage costs and add up to the billing, and this won't be actively used, so therefore we can review it and move this to be more cost effective overall. We can also use cross region snapshot copies whenever necessary to reduce the storage duplication cost, because the costs also vary in the AWS regions. Then we can scale as per demands. So using reader servers or read replicas only in time of demand is also a crucial aspect in cost saving. So forecasting the load and a respective resource usage before provisioning in case of any peak activities or peak period of any usage, we can forecast the load and what respective resource usage will be required, and we can provision based on that to stop the chances of overspending at the first place. Then we can simply turn off the unused instances. Another thing is to we can just simply turn off the RDS instances in lower or non-production environment when not in use. Also, we can also use the RDS pause and resume to temporarily suspend the DB instances and save costs. Also, we can use tools like AWS Instance Scheduler to start and stop the DB instances when not in use, because we will be only get charged when the DB instances are running, and whenever these are stopped or stopped or or put on hold, we won't be getting charged for the particular instances. Then another thing is to optimize network costs. As we know that AWS is having too many network regions is provided from AWS to deploy our services. So keeping the RDS servers or the RDS or the Aurora servers in the same region as the application services can minimize the data transfer cost, because cross region data transfer is again a part where the cost gets high. So it is suggested to avoid excessive cross region replication unless necessary. So we it is usually seen that the replicas are created in different regions to for a high availability perspective also. But in case we can keep one or two servers in different regions for high availability or for the DR, but whatever servers we are using for load balancing with a primary replica setup, we suggest to keep it in a single region in order to minimize the data transfer cost. We cannot reduce it to zero, but we can actually minimize it by keeping the servers to in one particular region. Thank you all for staying till the very end, and we believe this session will help you to learn from our story and apply what works for your DB infra to be more cost optimized.
Thank you for that insightful webinar on cost optimization techniques for AWS Postgres. And I hope everyone here found the strategies you shared today useful to their AWS environments. So, to quickly recap, we explored various techniques such as inventory analysis, instance type downgrades, optimized storage options, and managing snapshots, among others, to effectively reduce cost while maintaining performance. If you have any questions or need assistance in implementing these cost effective techniques, feel free to reach out to us at info@mydbops.com. Our team is always here to help with your database management and cost optimization needs. Lastly, don't forget to follow MyDBOps on LinkedIn, Twitter, and other social media platforms for updates on future webinars, blogs, and more. Please be sure to subscribe if you haven't already. Once again, thank you for being a part of MyDBOps My Webinar 40. We look forward to seeing you in our future webinars as well. Have a great weekend. Thank you.